Okay, in this lecture video, we're going to talk about compounds that contain covalent bonds. So you get covalent bonds when you have neutral atoms interacting. So unlike ionic bonds where you have positive and negatively charged cations and anions, in covalent bonds you have neutral atoms. They interact via the sharing of valence electrons, and there is a total of 2 electrons shared per covalent bond that's formed. Furthermore, they are composed entirely of nonmetals. So they are made of nonmetals. So anytime you see a metal, you do not have a covalent bond. So some common examples might be water, H2O, or sugar, C6H12O6. These are all examples of covalent compounds. And remember, the subscript in each one of these tells you how many of that particular atom you have. So for example, in water, you have 2 hydrogen atoms and you have 1 oxygen atom. And in sugar, this is the formula for glucose, you have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now, these are examples of compounds with covalent bonds, but you can also have elements with covalent bonds. I don't know what this word is. Let's just erase it because it doesn't mean anything. So you can also have elements with covalent bonds, and they're still elements because they're made between atoms of the same element. They're the same types of atom. So there are a total of 7, and we call them the 7 diatomic elements. That means there are 2 atoms in each one. And you're going to need to get familiar with these because they're going to come up a lot. So these diatomic elements that always exist as pairs when they're found in their elemental state. So the atoms are always paired in the element state. So if I tell you I'm talking about hydrogen gas, it's H2, nitrogen, N2. Then we've got oxygen, fluorine, iodine, chlorine, bromine, 1, 2, 3, 4, 5. That's all. Okay? So these are the 7 diatomic elements. So they never exist with their atoms alone. Now this bonding, where they're existing in pairs, that is only when they're in their elemental state. So when you have H2O, this is not regular old H2 gas that's in it. Instead, it's 2 H's. Okay? So they're completely separate from one another. In fact, each one of these H's is attached to an O. So if I wanted to demonstrate that structure, I could draw it like this. So each one of the H's in H2O is attached to an oxygen. Each one of these lines represents a covalent bond, and each covalent bond has in it 2 electrons being shared between the atoms. Likewise, just as a similar example about how you know how to draw these types of structures to show which atoms are bonded to which in a covalent compound. If we were to take calcium chloride, like this, first of all, you would know this was not a a compound with covalent bonds because it has a metal. But to be clear again, this Cl2 is not. It's not Cl2 because chlorine is a diatomic element. Since these chlorines are in a compound, the Cls are completely not associated with one another in this case. And we know that since this is a metal, that these Cls are actually 2 Cl minus. They are individual Cl minus particles, anions. So just to be clear, that the rule for having diatomic elements is only when those elements are by themselves. And we'll go ahead and go into more detail